Welcome again to this 13th event of Quantum Serbia on quantum computing. So today we have a pleasure to listen to hear the presentation of Radoica Draškić, Master of Sciences from Delft University of Technology, where he specialized in physics for quantum devices, quantum computing. The topic is how to become a quantum engineer. So before we start with this presentation, I would like just to say a couple of words about Quantum Serbia. We are a group of enthusiasts and professionals in quantum computing in Serbia and of Serbian origin. So our motivation is actually to learn together about quantum technologies, quantum computing, to network and to promote the development of quantum industry in Serbia. This group is open for everybody, also for non-Serbian speaking people from all over the world. And I invite you to join our platforms, meetup.com. I invite you also to check our previous presentations that we have saved in our YouTube channel, Quantum Serbia. You will be able also to find a couple of articles that we have written in our Medium publication, Quantum Serbia. And also I invite you to join our LinkedIn group. Just search for that and you'll see that we are already a couple of dozens of members there. So with this in mind, Radoica, please take over and guide us through all these exciting slides that you have prepared. I would just ask everybody to go on mute, and you can also deactivate the camera so that we give full attention to Radoica. Okay, thank you.
Thank you, Sasha. So thank you all for coming in such a big number, and thank you to Quantum Serbia for inviting me to give a lecture. If you have any questions during the talk, just write them in the chat. Maybe Sasha can interrupt me and read it to me since I won't be able to see the chat regularly. So the topic that I chose for today's presentation is how to become a quantum engineer. I hope some of you might get interested more into learning about quantum technologies and maybe getting involved after this presentation. And I'll now start. So you should see now the slides changing. If you don't see them, tell me. So basically, maybe some of you heard about this new breakthrough in AI, ChatGPT. It's a chatbot developed by OpenAI, and everyone is super excited about it. And everyone is trying it out, and it's everyone is super happy about how smart it is and how it can reply with super smart responses. So I was playing around with it. I saw one of the example questions that they propose when you log in is what is quantum computing? And I asked it like how to become a quantum engineer. And I got a very interesting response. I mean, it's a true response, but it might not be too helpful. So basically it says to become a quantum engineer, you need to have a strong background in physics, math, and computer science. You might also need to have experience with quantum computing, which you can gain through coursework, internship, or research experience. Additionally, you'll have to have strong problem-solving and analytical skills, as well as the ability to work in a team. So, I mean, this is in short what this presentation will also contain, but this short paragraph is like not too helpful. It basically, this is something you can see in every job description. Like every tech position wants you to have strong problem solving and analytical skills and the ability to work in a team. And of course, if you want to do quantum, you should have experience with quantum. So this is not a deep answer, but maybe like you browsed the internet, you saw some other lectures, some blog posts, and where people describe their experience and how they got into the field, and their vision of where the field is going. And so I'll start with that. So I'll quickly talk about my path to quantum computing, how I got interested in the field. And so basically, I'm from Serbia. I studied in Belgrade, studied for a bachelor's degree in theoretical physics and in computer science. Since there are not so many opportunities to do like quantum computing related stuff in Serbia, I mostly focused on some other internships at the Institute of Physics and some other software companies where I worked as a software engineering intern. I participated in programming and physics competitions during my undergraduate studies. And I was sort of always interested in connecting my interest in physics, math, and computer science. And I heard about quantum computing already early on, I think as soon as I started my undergraduate studies. And I was very curious about the field. I thought maybe this is something that will help me do all the stuff that I find interesting. So I sort of researched about it, tried to extend more on my coursework. So I had, as part of my physics degree, I had quantum mechanics courses. So when I studied for those courses where I had to do some presentations or stuff like that, I always chose some quantum computing related topic to use the opportunity to explore more. And I also, after finishing my undergraduate studies, I applied to several master's programs abroad, and I was fortunate enough to get a scholarship to attend the master's in applied physics at Delft University of Technology in the Netherlands. And from 2019, I was doing my master's studies. I finally got more involved into the quantum computing field. I did some research internships in Delft and Leiden University during my studies. I was also teaching assistant for some of the quantum computing courses that I also took in my first semester there. And also during the summer breaks, I was an intern at startups, Quantum Machines and Xanadu. And I also tried to get involved in the field, made some appearances in hackathons that were organized by some of these companies and my friends. And basically, so this is a short story. But why would you get interested into the quantum computing? So until recently, most of these things have been done in the academic setting. So let's say past 20, 30 years, all of the breakthroughs happened at universities. So first qubits, first quantum algorithms executed. There were all of those breakthroughs were performed at universities. And in the last few years, you might have seen some big announcements from some of the big companies like IBM, Google, or Microsoft that also joined the efforts to develop quantum computing. For example, Google announced its quantum supremacy experiment in 2019, and IBM is building bigger and bigger quantum chips every year. And like a lot has changed in the last 5 years. And there are big investments both from venture capital and governments like USA, Canada, China, Australia, and many others like Netherlands. And already the investments worldwide into quantum computing are already in the range of billions. For example, Netherlands, where I was studying, this year, the government decided to invest over 600 million euros over the next few years into the research and development and helping startups. And there are also like hundreds of startups globally popping up. People are trying to position themselves to develop the market. And for now, the biggest players are already the established industry leaders like IBM and Google that already have the biggest chips, one of the biggest chips in the industry. And now it feels like it has become a real industry. So until like 5 years ago, most of the work has been done in academy, and some of the startups that have been created are actually just groups of professors that just decided to start a company. And now that the field has already matured, there are many opportunities for others to join and to try it out and to participate in the development. And I just did a quick search on LinkedIn for open positions that are with keyword quantum computing, and there's already more than 11,000 matches. And so there are already open positions in thousands, and I think now companies are struggling to find talent since not many people are actually haven't actually heard about it or are on their path to getting involved. So, for example, what are some advertised positions? Usually, there are still researcher positions that are mostly open, so most of the people are still researchers. But there are also positions for hardware engineers, electronics engineers, scientific software engineers, infrastructure engineers. There are also educators. There's a bunch of internships, but also some companies that don't have full quantum teams yet, and are not yet maybe using anything quantum computing related, are employing analysts to explore this new field, like to see if there is something there that can be interesting for their use case. And also, what's interesting that should not be discarded is the sales and marketing. I think sales and marketing in quantum computing are very specific. The market is just starting and figuring out how to get your product to the customers. I think is very, very different from the other fields, and I think it requires a lot of creativity. So, of course, this talk will be biased more towards the engineering because of my experience, and so I'll quickly describe some of the positions that I had the opportunity to encounter. So one of them is researcher, and research positions they usually require a PhD, and they usually involve some sort of publishing. So if you saw that Google Quantum Supremacy Experiment, it was actually a publication, and most of the leads of that project they have PhD, they were also professors at one point. And a researcher's job usually involves developing proprietary technology and patents. And most of the people with a PhD end up in leadership positions simply because they're already more familiar with the field. They have some sort of a vision of what the product might look like and where the company should move. But there are also people with PhDs doing all other kinds of jobs. For example, educators that organize hackathons or write blog posts or engage with the community. And So of course, to become a researcher, you face big competition. So this is like usually companies get like tens of applications for a single position, but there's also another very important position, which is quantum software engineer. So this sometimes doesn't require quantum computing background, usually requires some software engineering background, and but of course there are also a lot of PhDs doing this kind of job. It ends up being the scope of the job is implementing research papers or developing tools for researchers and other engineers. And currently popular programming languages are like Python, Julia, C++, and Go. Quantum software engineer is something like maybe some of you are familiar with machine learning and AI industry, where there's something like a machine learning research engineer position in a lot of companies. And yeah, that position usually involves something similar. So implementing research papers, developing some tools, and basically it requires some sort of domain expertise, but still the focus is on software engineering. And it can be very interesting to, like, if you like physics and if you're excited about quantum computing, this might be a popular option, because you don't need to know all the super mathematical theory and all the newest developments in the field to do an important job. And so these are some of the positions that I had experience with, but I'll go back to this slide. So currently there are a lot of internships. So as you can see here on the right, a lot of companies startups are employing bachelor's or master's students, sometimes even PhD students, to spend some time with them, do a project, try to develop some technology. Usually, so how this usually works is, if you specialize in something during your master's degree, for example, a company that's doing something related will be super happy to have you. Yeah, there's also something called evangelist or community builder. So those are people that engage with the community, organize events, help spread the word about quantum computing, talk to maybe investors or whatever, try to get more people involved. And also some positions that I didn't have much experience with, but are very important, are hardware related and electronics related. So I think currently the core part of the quantum engineering is to develop the quantum chips, this hardware where the algorithms will end up running. And that's currently the place where the biggest breakthroughs are actually needed. And once we have chips that we can use and that can be scaled, then the job of software engineers and algorithm engineers will be much easier. Yeah, so now the next question is how to learn about quantum computing, how to get involved, since other engineering disciplines currently have a sort of predetermined education path, but for quantum engineering you might have to define your own path. So it's not so simple, but for example, if you want to do software engineering, you usually enroll into a computer science program, and that's pretty much their courses haven't changed much in the last 20 years or so, and it's pretty clear what you need to study. But I would argue, like the same way that you don't need like super theoretical computer science courses or concepts to do a software engineering job. In the same way, you don't need like deep understanding of physics and theory to contribute into the field of quantum computing, because the biggest effort in the end will be in the engineering part, and people will actually have to build these things and build the infrastructure for people to use it. And that's a lot of, just engineering work that requires a broad set of skills. And usually you don't have to do some super abstract math to do a good job. And so what are some current ways that people get into field are blogs or talks like this one. So you can follow someone that you find inspiring and read up on their thoughts in the field, or follow some blogs by some companies where they write about their recent efforts or breakthroughs, and see where the field is going. There is also a lot of online courses. So in the past, like 2 or 3 years, this has really expanded. So there are a lot of also free and paid online courses that you can take. You can maybe even get some certifications, and you'll basically see the lectures of the famous professors from the top universities around the world. And so already, if you don't have opportunities to study in a specialized program, you can already just do it from your home, try to get involved and learn at your own pace. So, but also one big part that's now becoming a reality is attending specialized programs. So, for example, I attended a specialized master's track where most of my courses were related to quantum computing. I had like almost like 10 courses related to quantum computing, and all of my projects that I did were also related to quantum computing research. And there are not so many programs of that sort around the world, but more are coming out every year. So there are even some undergraduate programs that I've seen coming out. So for example, in Australia, I saw one bachelor's program which is already focused on quantum computing. I think, also in the Netherlands at TU Delft, where I studied, there is also a lot of undergraduate courses in quantum computing. So people can already get involved at an early stage and be able to get some opportunities even during their undergraduate studies. Also, there are some summer schools organized by various institutes or universities. For example, one popular summer school is organized by University of Waterloo in Canada, and some companies are also organizing coding boot camps. So, for example, IBM, where you can learn to use Qiskit and make a project with some of the other participants, collaborate, meet people. And there are also a lot of hackathons and coding challenges. They're organized by these companies. And there's also a lot of open source software. So for example, a lot of academic research groups develop some software tools, and soon after their publication, they release it on GitHub or similar platforms, and so that the rest of the community can contribute. And there's also a Quantum Open Source Foundation that focuses on this, and also gives grants to people that want to contribute to open source. And there are also hackathons organized to give some bounties to people that improve these repositories and or use them in some interesting projects. And yeah, so one of the biggest ways you can actually get involved if you don't have an opportunity to study at universities is to make personal projects and research on your own. And this is something that might sound scary and super hard, but actually now that the field has developed like already in the last few years, like every few years there's been a doubling of the amount of software frameworks for quantum computing. So now there's a bunch of them. You can even, some of them before were, for example, only in Python. Now you have Julia, C++. You even have some special languages like Q# by Microsoft. So you have a lot of choices there. There's also a lot of materials, blog posts. It's easy to get involved. So there's a lot of already implemented research papers. You can try to understand those implementations, try to modify them. When you get an idea of your own, you can quickly try it out. So that's now super exciting. Also, a lot of companies and some academic institutions have put their quantum processors into the cloud. So now we can access them online. So for example, IBM, you probably heard, and some other companies like IonQ. You can basically write your program in the framework that you like, for example, PennyLane, and it will be converted to these basic instructions that are then sent to be executed on a hardware platform that you can specify. And now there are many opportunities, even for people that are not researchers, to try it out and to see like if they have some new ideas and to maybe create something new. But how to get opportunities? Now, this might be a painful process, so it might take a long time. For example, during my bachelor's studies, I applied to many internships, to many summer schools, and since all of them were abroad, usually you have to get paid. Someone has to pay for your plane tickets or whatever, and there is not so many paid positions, and usually the competition is tough. And yeah, at the time I didn't get any of those opportunities. But as soon as you sort of break through, at least get one opportunity, everything becomes much easier. So probably, I guess this is the experience of the other people as well. For example, if some of you are in software engineering, once you get an internship in one of the big tech companies like Facebook, Google, or Microsoft, now it gets much easier to find a job after you graduate. And it's similar in quantum computing. And if you have the opportunity, I would definitely recommend apply for specialized programs. So if you want to do your master's after your bachelor's, so for example, if you only studied computer science, but you don't know much about the physics side, then something like this will be definitely helpful. And there are a lot of scholarships available out there. So most of these universities are trying to attract students to enroll into these programs. And for example, at TU Delft, where I studied, there was around 50 students in the program, and there was like around 10 scholarships, which is quite a lot. Usually there are only a few scholarships for the entire, let's say, faculty. For example, if the faculty of computer science has like 1,000 students, and there's only a few scholarships. But for example, at some universities like at TU Delft, there are specific scholarships only for people that want to study quantum computing, which is super great. So you can we can search those and see which one we might like, and also contributing to open source projects and participating in hackathons gives you visibility. So people will see that you are engaging and that you're contributing to the field. So for example, I think how I got an interview for this internship at Xanadu is by participating in their hackathon, and I did well on their challenges, and yeah, they basically remembered my name. Once I got interviewed, they told me, yeah, we know you participated. Congrats. And I was super happy that it was recognized. And so there is definitely a way to be recognized. And there is also that, I mean, a lot of people apply to these positions, and so you have to signal in some way that you're really enthusiastic and that you are ready to jump right in and to contribute. And also, I mean, previous experience is always a big plus. So there might be a bigger competition joining companies, but there is a lot of open positions with in the academy as well. So if you're interested in some of the research that some professor is doing, you can definitely just send them an email, cold email, tell them that you find the research interesting, but try to avoid default emails, like show interest and understanding of what they do, maybe give some idea of how would you like to explore their ideas, and maybe give some proposals for a project. And I think like professors are super eager to get you on board once they see that you know what you're doing, sort of. So they'll be there to guide you, but it's not usually not a big investment from their part. So they'll see you maybe like once or twice a week to collaborate with you. You can also do it remotely now. And there are also some positions like professors will pay you to come for a month or 2 or 3, visit their group, and meet the students, do the research, even during your undergraduate studies. So there is a lot of positions that are sort of not advertised, right? So if you only look for the advertised positions, maybe you're missing out. So definitely reach out to people. I mean, if they don't respond, don't take it personally. You're probably not the only one. But sometimes if there is a match, I mean, it might definitely help you a lot. And yeah, one other way is to network, on all the social media, reach out to people, connect with people, ask for recommendations, do a project with someone that can then recommend you, stuff like that. Or if you have some interesting ideas, or maybe during your study process, you made some writings, maybe put it out, post it on a blog or something, do some personal projects, put them on GitHub. People will definitely notice, and you might get an opportunity that you didn't even expect. Like someone will reach out to you and say, "Oh, I find this very interesting. Are you free for a chat?" And then you can make an entire project out of a 15-minute chat. So yeah, some of the potential applications of quantum computing are varied. Like some people are proposing applications in machine learning, drug discovery, material science, financial modeling, or optimization problems. And there is a bunch of companies working specifically in one of these areas. So they're focused, for example, on drug discovery. And because they expect that in the near future, once the powerful quantum chips are available, they can make a real difference. And you can also choose your niche. So you can, if you have some specific background, you can definitely, it might be definitely helpful to join one of these. For example, if you studied chemistry, even though you might have you don't have a lot of like software engineering experience, or quantum computing experience, you might definitely be able to get a position that's related to materials science or drug discovery, since their quantum computing is mostly viewed as a tool, and there's a lot of open opportunities. But also now that all of these platforms are available over the cloud, I mean, maybe you can come up with your own application. You can try them out, see if you have some idea, code it up, send it, get the results, and see what happens. So most of these ideas, most of these fields that sort of got established already, they got established because they are currently like these hype fields. So everyone is excited about AI and machine learning, and people are trying to figure out how to expand its scope even more. Or like drug discovery, something that's very important, and people are trying to use every new technology to see if they can make some improvements. So, but maybe like once the field matures more, maybe these applications are like decades away. But some not as hyped fields might be actually more reasonable, and you might be able to find at least some small improvement in some process that's enabled by quantum computing and that you can profit on. And so I believe like there'll be a lot of applications that are currently not even thought about that will pop out in the next few years once the people start using these chips and experimenting with them. So in the end, so what are some of the key takeaways that I would like you to have from this talk is to put yourself out there. So join the community and participate in the events, talk to people. I mean, community is still small, so it's super easy to get to people. Like in some other fields where there is like tens of thousands, hundreds of thousands of people, you might get confused who to reach out to, because there are so many people, most of whom might not respond. But in quantum computing, I found that most of the people are quite eager to tell you about what they're doing. So if you reach out to some PhD student and tell them like, hey, I'm interested in your paper, I think it's really cool, this is my opinion, like they'll definitely respond. And yeah, so find opportunities to collaborate if you want to join the field, maybe join some other enthusiasts, or try to find some mentor. So mentor doesn't have to be a professor, it can be someone else who's already in the field a bit longer, or some other student, or some master student, a PhD student. And also, like as I say, like timing the market beats timing the market. So being in this field for a long time definitely helps you. So you sort of get the experience of what's happening around you, and once you're exposed for a long enough time, that definitely helps. And also there are non-technical positions that are now sought. So as I mentioned before, for example, sales and marketing, those are something that like almost every company has, and but quantum industry has specific needs, and the products are very specific, and already in order to do those jobs good, you need to have some idea of what quantum computing is about. And yeah, so in the end, like try it out, maybe you can make something new. So definitely I believe there are a lot of opportunities that will be open in the future, and I think the field is just gonna keep growing. And yeah, with that I would like to end, and thank you for listening, and now we can maybe open for Q&A.
Hey, thank you, Radoica. So thank you for this excellent talk. Yeah, let's open the Q&A part of our session. Let me go through the chat. If anybody has a question, feel free to.
Okay, I'll go to the chat. I see there are some questions. So yeah. There's a question: can you recommend an online course? Well, I mean, there's a lot of courses. I saw some courses by MIT on edX platform, I think, or there's also there's a bunch of courses made by professors from TU Delft, where I studied. So some of my friends from my master's program were also contributing and participating in the creation of those courses. So they recorded themselves going through some problems, and basically you have even some math worked out in those lectures, and it's very helpful if you want to have a deeper dive to understand more into like physics part of things. So I mean, there's a bunch of courses. Like, if you want to go really into depth, I mean, you can always just find a course that's given at the university, see their webpage, go through homeworks. Maybe they have some recorded lectures, since a lot of the lectures have been remote in the past few years. But yeah, I don't have one specific in mind, but maybe you can search for the ones given by TU Delft. So there is a question: any advice for experienced engineers looking to transfer to quantum software engineering? For example, what kind of companies to look for? Are startups a good idea for that situation? Are there any known possibilities in Serbia for quantum engineering? So yeah, I saw a lot of people that were software engineers in completely unrelated fields that have transferred, and they mostly transferred by being super enthusiastic about the field. They tried out by themselves. They maybe participating in some open source projects, talked to people, reached out to them on LinkedIn, and there is a lot of companies looking for software engineers that do not necessarily have to know anything about quantum computing. For example, a lot of the companies have platforms that through which they give access to their quantum computers, and the entire infrastructure has to be maintained. So there are like DevOps positions and also other software engineering positions. Yeah, I mean, startups are definitely a good idea. So there's a lot of startups that need people with those profiles. I mean, also big companies as well. But from what I saw, maybe bigger companies, what they usually do is they move people inside the company to form new teams. So for example, if someone was already a software engineer at Google, now they just get moved to a team that's related to quantum computing. So it might be a bit more competitive to get into the big companies that way. But I've definitely seen a lot of people get into startups. And for Serbia, I mean, currently I haven't seen many open positions. I think I saw one position in Belgrade a few months ago for a quantum computing researcher. So one company wanted to explore, I think, if they can use quantum computing to improve their product. So they're looking for one person just to analyze the field and to see if there are any matches with what their problem. But I think there's a lot of possibilities to do remote work. So a lot of the companies allow you to work from anywhere in the world. So for example, when I did my internship for Quantum Machines, I actually did it from Belgrade because it was during Corona times, and my mentor was actually working from Paris, and my manager was in Tel Aviv. So two of the people, like three of us, we were all around the world, and we were collaborating daily. So I think that's definitely a possibility. Okay, so next one. I would like to hear your advice on how to go for a path of quantum computing / engineering for experienced physicians. I'm interested in the subject of consciousness and quantum and its application to medicine and medical sciences. So I saw some people trying to research in this area. I mean, this is still super speculative. I saw some professor from maybe UCLA, I don't remember. They're exploring quantum biology. So they're trying to understand, maybe some of you saw how there was a post and how maybe quantum computing has something to do with consciousness. And I guess we don't know yet, but it might be an interesting option to explore. I mean, we think that maybe some animals use some quantum effects. For example, birds might use some quantum effects to navigate. So that's already pretty crazy. And if there is a connection there, I mean, that would be groundbreaking. But I don't have any particular advice. I think it's just super new and super out there. So it's just, I don't think many people are working on it yet. Okay. Yes, the next one is, what is a platform you would recommend with lots of quantum computing resources and research paper? Is there a platform to look for scholarships on quantum computing? How did you find about your scholarship? Oh, so well, currently this is all scattered, so there is not a particularly good advice there. I mean, one blog that really excited me was Xanadu's blog, Penny Lane blog, where they showed a lot of examples in Penny Lane, and that's how I got interested into applied quantum algorithms, and where I saw these examples in quantum chemistry or quantum optimization. And but I mean, there's a lot of resources by Google, IBM, and Microsoft as well. It just depends like what you find easier. So sometimes if you already know Python, then maybe Qiskit and Penny Lane are easy to pick up quickly. But if you don't care at all, like maybe you can choose some other language that you find interesting. I mean, some other companies maybe use Julia. So yeah, it depends what your background is. How I found my scholarship? Well, basically I didn't find it on a single website, so I searched for days, like what are the programs that exist out there. I dug through the websites and made a big spreadsheet of all the programs and how many scholarships they offer and what were the deadlines and what were the requirements. So maybe there is a website now, I don't know, but I think it's mostly scattered around. Okay. Can you recommend any quantum physics and engineering resources, any workplaces available opportunities in the UK? Well, I don't know particularly about UK, so I guess, yeah, I mean, you can search it up online. I don't know, I heard about Quantinuum, so that's a big startup in the UK. I think they have a lot of open positions. Okay. Okay, I think that's pretty much it. Thank you so much for the questions.
Thank you, Radoica, for answering and going through all of them. I have one question actually I wanted to ask you. So once when you get the education, actually, I mean, like this, you know, quantum engineering, master sciences, or so I assume this is a kind of, you know, general education in quantum engineering. So then, what is, in your point of view, the best strategy then? How to position yourself after this education? Is it maybe, you know, to focus on one particular area, like I don't know, quantum machine learning, or maybe medical use, as we have seen here, the question coming from Najwa about how to use, I mean, quantum computing and quantum physics in health science, or you suggest actually to explore, I mean, to stay more kind of, to develop your foundations, like work in different fields, like trying different things in order to, I mean, stay in contact in a kind of more general sense with the field.
Yeah, thank you for the question. Well, I mean, I personally picked up this second path. I mean, I'm curious about so many different areas and field and things, and I still like to explore. I mean, I think that the field is changing like daily, and maybe something that's popular today might not be popular next year, or there might be some deceleration in some areas. And I think like understanding the fundamentals is definitely helpful and important if you want to do engineering, and if you want to focus explicitly on quantum, you definitely need to understand the basics, so to have something of equivalent of an introductory course. But after that, I mean, you can explore like anything that you like, and we don't know yet what application might be the most useful one. So some companies focus on drug discovery, but maybe if the field isn't ready yet for that, and if nothing happens in the next 5 to 10 years, maybe they'll have to slow down, maybe pivot to something else. So it's hard. I mean, but that's also not a bad thing. I mean, a lot of people are changing jobs these days, especially in engineering. Like people usually work like 2 or 3 years in a single place. And I mean, if someone is interested, I would definitely encourage to try some new field and see if they like it. I mean, people usually have something that they're already interested about. For example, machine learning, and exploring, for example, quantum machine learning might be very interesting for them to see another point of view. And if it doesn't work out, I mean, it's not the end of the world. I mean, machine learning, for example, has changed over decades a lot. Like there was even a AI winter, so where there was a lot of people were discouraged about the field, but now everyone is super excited about it again. So things change. Maybe some ideas are ahead of their time, but yeah, that's it.
Yeah. Okay. Thanks a lot. Before we close, actually, and if anybody would like to ask any additional question, I mean, it's feel free to type, but please quickly hurry up. I would like to thank once again to Radoica and to invite all of you to check our Meetup events page on meetup.com, Quantum Serbia, for new events that we are going to announce for the near future. And also to invite you, actually, if you have not checked already, there is very soon another event with a local physical presence. And this is the first time that actually we are organizing a local event in Belgrade. So Radoica is going to talk again on Sunday this week, 18th of December, at Electro Engineering School in Belgrade. This is a joint event with Google Developer Students Club. And the talk of Radoica is going to be the introduction to quantum computing. So he will do some practical introduction, what quantum computing is. And also he's going to talk about CERC. So this is Google framework for developing quantum algorithms. So as this is the first local event in Belgrade, or for all of those who are actually there in Belgrade, this is the opportunity to socialize, to learn something new, and to meet directly. So thanks, thank you, Radoica, and thanks to all of you who joined this event. So take care, and if we don't hear again before the end of year, happy holidays, and see you soon. Thank you.
Thank you, everyone.